This is my lab on the motion of a falling object. The purpose of this lab is to compare the observed motion of a falling object to the simulated motion of a falling object, analyzing position, time, and drag versus no drag. Models and principles used: Tracker software was used, GlowScript software was used, and Google Sheets was used. Newton's second law is an important principle, which says that the force applies to an object is equal to the rate of change of its momentum, or just F equals ma for short. And then I also included the position update formula, velocity update formula, and the force of gravity and drag, which you see here, those formulas laid out here as well. The result preview, you can see the observed versus predicted. This is the final result, and I'll explain how we get to this. But basically, a falling object position versus time graph for both observed position, model position, and model position plus drag. The system and surroundings. The system in this case is the white cloth falling from the wall to the floor, and the surroundings are the wall and the floor. The initial conditions: pre-coding, cloth mass is 0.45, the initial position vector is 0.126 and 0, and we only care about the y direction in this case because we're dropping the cloth straight down vertically, so the x and z directions aren't relevant in this case. And then the change in time is 0.033, and then the time of the last observation is 0.534. First part of the procedure for the video and tracker. The video was taken, the video was uploaded to the tracker tools were then used to analyze the video, and data was collected from time and position, and that data was added to a spreadsheet. Then for the coding portion of the procedure, this was necessary for the gravity and no drag models as well as the gravity and drag models. So the system mass was edited to be 0.45. That was the mass that I found. And so I didn't change any of the words here. I changed just the number, so that's why it still says ball throughout, and it doesn't say cloth, but all of the numbers were updated. So the ball mass, well, in this case, cloth mass was 0.45, and then the proportionality constant in this case is 0 because we are not taking into account the drag force. So that is not necessary in this case, just the force of gravity. And then this other red box was moved, but it should be showing the while t is less than 0.53 seconds because that was the time of the last observation. So the while t is less than 0.53 seconds is true, the while loop will then run. And then I updated the object's velocity formula and the object's position formula here so that the code would run correctly, and then ran the model. For gravity and drag, the code is slightly different. So now that we have the drag force that we're taking into account, we do have to calculate the proportionality constant. And so I found that the proportionality constant was 0.025. And then to calculate the net force, first had to find the cloth speed, the force due to gravity, the force of drag, and then the net force was the combination of those two forces. And then I ran the model this way and collected the data from both the gravity and gravity without drag. This running the model is just, I believe, the no drag model, but it basically just shows you the position versus time graph and a velocity versus time graph. Then for results and what if, taking into account terminal velocity. First, the falling object position versus time graph, you can see that what the model position with drag looks like, what the model position without drag looks like, and what the observed position looks like. And so you can kind of see that there's some slight variation between the three of these. One possible reason for the observed position being slightly different than the others is because of other sort of forces or environmental factors that weren't taken into account in the data collection, such as maybe the vent beneath the wall was blowing air out and that was affecting the cloth's movement on the way down, or maybe the points in the tracker software that were collected weren't collected entirely accurate when tracking the object in the tracker software. And so those are things that may be affecting this model here. But as far as terminal velocity is the constant speed that a free falling object eventually reaches when the resistance of the means through which it's falling prevent further acceleration. And so terminal velocity is when occurs when net force is zero. And so in the gravity model, the net force will not ever reach zero because you'll always have the force of gravity and nothing to balance that out. And the ball's speed, or in this case, the cloth speed, will continue to increase. But if the object was to be thrown down, the terminal velocity would be the same, but it would be reached in less time because there would be a boost, because now you're throwing it instead of just dropping it down. So that's kind of a hypothetical scenario with terminal velocity. And that concludes this lab.